Hey, my name is Sandeep Tekchandani. I'm the founder of Sandeep.mba and welcome to my GMAT video lesson. In this video lesson, we'll learn coordinate geometry. We'll brush up the following concepts: coordinate plane, distance between 2 points, the equation of a line, slope fundamentals, coordinate plane and linear equations, coordinate plane and functions, and eventually parabola. So let's start with the coordinate plane. The figure shown over here is called the coordinate plane or the Cartesian plane. The horizontal line is called the x-axis and the vertical perpendicular line is called the y-axis. The point at which these two axes intersect, designated O, is called the origin. The two axes divide the plane into four quadrants. They are 1, 2, 3, and 4. Each point in the plane has an x coordinate and a y coordinate. A point is identified by an ordered pair of numbers in which the x coordinate is the first number and the y coordinate is the second number. For example, in the graph shown, the xy coordinates of point P are 2, 3. Similarly, the xy coordinates of point Q are -4, -3. The origin has coordinates 0, 0. In this slide, we'll talk about how to find the distance between 2 points in the coordinate plane. One way to find the distance between 2 points in the coordinate plane is to use the Pythagoras theorem. To find the distance between points R and S using the Pythagoras theorem, you must first draw the triangle as shown. Please note that the point Z has coordinates -2, -3. The length of RZ is 7 and the length of ZS is equals to 5. Therefore, the distance between the points R and S is equals to the square root of 7 square plus 5 square is equals to the square root of 74. In this slide, we'll talk about the equation of a line. For a line in the coordinate plane, the coordinates of each point on the line satisfy a linear equation of the form y is equals to mx plus b or x is equals to a if the line is vertical. For example, each point on the line shown satisfies the equation y is equals to -x upon 2 plus 1. One can verify this for the points -2, 2, 0, 1, and 2, 0 by substituting the respective coordinates for x and y in the equation. In the equation, y is equals to mx plus b of a line, the coefficient m is the slope of the line and the constant term b is the y-intercept of the line. For any 2 points on the line, the slope is defined to be the ratio of the difference in the y-coordinates to the difference in x-coordinates. For example, using -2, 2 and 2, 0, the slope is the difference in the y-coordinates upon the difference in x-coordinates. Hence, the slope of the line is -2 upon 4 or -1 upon 2. The y-intercept is the y-coordinate of the point at which the line intersects the y-axis. For the line shown, the y-intercept is 1. And this is the resulting value of y when x is set equals to 0 in the equation. Y is equals to -x upon 2 plus 1. The x-intercept is the x-coordinate of the point at which the line intersects the x-axis. The x-intercept can be found by setting y is equals to 0 and solving for x. For the line y is equals to -x upon 2 plus 1, this gives -half x plus 1 is equals to 0. In the next step, I'll subtract 1 from both the sides of the equation and get minus half x is equals to minus 1. In the eventual step, I'll divide the entire equation by minus half and get the value of x is equals to 2. Thus, one can conclude that the x-intercept of this line is 2. Given any 2 points, x1, y1 and x2, y2 with x1 not is equals to x2, the equation of the line passing through these points can be found by applying the definition of slope. Since the slope is m is equals to y2 minus y1 upon x2 minus x1, then using a point known to be on the line, say x1, y1, any point x comma y on the line must satisfy y minus y1 upon x minus x1 is equals to m, or y minus y1 is equals to m times x minus x1. Using x2, y2 as the known point would yield an equivalent equation. For example, consider the points minus 2, 4 and 3, minus 3 on the line shown. The slope of the line is as follows. The difference in the y coordinates upon the difference in x coordinates is equals to minus 7 upon 5. So an equation of this line can be found by using the point 3, minus 3 as follows. Y minus minus 3 is equals to minus 7 upon 5 x minus 3. So y plus 3 is equals to minus 7x upon 5 plus 21 upon 5. Therefore, y is equals to minus 7x upon 5 plus 6 upon 5. Hence, we can conclude that the y-intercept is 6 upon 5. The x-intercept can be found as follows. 0 is equals to minus 7x upon 5 plus 6 upon 5. Therefore, 7x upon 5 is equals to 6 upon 5. 5 and 5 will get cancelled and we'll get 7x is equals to 6. If 7x is equals to 6, then x is equals to 6 upon 7. Please note that both of these intercepts can be seen on the graph. Here is our x-intercept and here is our y-intercept. In this slide, we'll study some very important rules governing the slope of a line. If the slope of a line is negative, then the line slants downward from left to right. If the slope is positive, then the line slants upward. If the slope is 0, then the line is horizontal and the equation of such a line is of the form y is equals to b since m is equals to 0. Finally, for a vertical line, the slope is not defined and the equation is of the form x is equals to a, where a is the x-intercept. There is a connection between graphs of lines in the coordinate plane and solutions of two linear equations with two unknowns. If two linear equations with unknowns x and y have a unique solution, then the graphs of the equations are two lines that intersect in one point, which is the solution. If the equations are equivalent, then they represent the same line with infinitely many points or solutions. If the equations have no solution at all, then they represent parallel lines which do not intersect. There is also a connection between functions and the coordinate plane. If a function is graphed in the coordinate plane, the function can be understood in different and useful ways. Consider the function defined by f of x is equals to minus 7x upon 5 plus 6 upon 5. If the value of the function f of x is equated with the variable y, then the graph of the function in the xy coordinate plane is simply the graph of the equation y is equals to minus 7x upon 5 plus 6 upon 5 as shown in the slide over here. Similarly, any function f of x can be graphed by equating y with the value of the function y is equals to f of x. So, for any x in the domain of the function f, the point with coordinates x comma f of x is on the graph of f, and the graph consists entirely of these points. As another example, consider a quadratic polynomial function defined by f of x is equals to x square minus 1. One can plot several points x comma f of x on the graph to understand the connection between a function and its graph. So I have taken some values of x arbitrarily. The values of x are -2, -1, 0, 1 and 2. And the corresponding values of f of x are 3, 0, -1, 0 and 3 respectively. So if I plot these points on a graph, then they will look like this. Here are our points -2, 3, -1, 0, 0, -1, 2, 3 and 1, 0. If all the points were graph for x greater than or equals to -2 but less than or equals to 2, then the graph would appear as shown in this slide. The graph of a quadratic function is called a parabola, and it always has the shape of the curve as shown here, although it may be upside down or have a greater or lesser width. Please note that the roots of the equation f of x is equals to x square minus 1 is equals to 0 are x is equals to 1 and x is equals to -1. These roots coincide with the x-intercepts, since x-intercepts can be found by setting y is equals to 0 and solving for x. Also, the y-intercept is f of 0 is equals to -1 because this is the value of y corresponding to x is equals to 0. For any function f, the x-intercepts are the solutions of the equation f of x is equals to 0 and the y-intercept is the value f of 0. So let's just summarize. What did we learn in this video lesson? We started with the coordinate plane. Then we learned how to find the distance between 2 points. What do you mean by the equation of a line? What are the important rules that govern the slope of a line? What's the connection between the coordinate plane and linear equations? What's the connection between coordinate plane and functions? And eventually, parabola. I hope my video lesson was clear and it will help you in your exams. That's all, my friends. If you found my video lesson helpful, then you should go to sandeep.mba for more information on the GMAT, how to prepare for the GMAT and applying to business schools. You should also click on that like button and let me know in the comments which topics you would like me to cover in my future video lessons. And of course, if you have not yet subscribed, then go ahead and click on that bell so that you'll get notified about my future video lessons. All the best.